Okay, guys, just want to talk about basic atomic structure and kind of introduce to you, give you an idea how to just kind of look at this periodic table of elements and make some sense of it. So I'm going to start by just taking this particular square right here and blowing it up kind of big. Okay, so I'm going to take that square and make it big right here. I'm going to write the atomic symbol, okay, which stands for boron, which is one of the elements in group 13. Okay, I'm going to put the atomic number above it. I'm even going to label that atomic number. Because often you'll forget. Now, which one of those numbers is the atomic mass and which one of those is the atomic number? And I just want you to be able to look back at this video over and over again and go, oh, okay, that's the one. And then I'm going to write, as it is, the atomic mass, the average atomic mass. So what this is saying is that most of the time the atomic mass is 11, and every now and then it's 10. So that's what that says, because it's really close to the number 11, 10.8, and it's not very close to 10. So what that means is that boron 10 is very rare, but boron 11 is quite common, and we'll get into that. Okay, this is what's called the atomic mass. Okay, so just for the time being, just for now, since I've got this blown up, I'm going to get this out of here. And we're going to look at what exactly this means. Okay, so for starters, the atomic number, what that means is that on the inside, and I'm going to make kind of a fun little, what's called a Bohr model, kind of a cartoony version of an atom that would never look like this in a million years, but it helps you know what the parts are. So I'm going to take atomic number, and that means the number of protons, little positively charged subatomic particles on the inside of an atom in its nucleus. There's going to be 5 of them. Okay, that's what that means, the atomic number. Now, whatever the atomic number is, that's the number of protons. Also, oh, and just for fun, just to make it easier, I'm going to put little pluses in here so that you're like, oh yeah, those are positive charge. Those are positive charges. Okay. Cool. Now I'm going to draw a valence shell that's kind of going around the outer edge of this nucleus. And I'm going to put 2 electrons, negatively charged electrons, buzzing around outside, because that's how many fill up this innermost valence shell. 2. And they're just kind of buzzing around. When I draw it like this, it really doesn't show how electrons truly orbit. It makes it look like they're going whoo, whoo, whoo around this electron, but really it'd be like a ball. They're just spinning all over the place, you know, like an airplane propeller, so fast they could never be seen. Now, I've got 2 negatives here, and then I've got 5 positives in here. So I have to go one more shell out in order to make this thing balanced. Okay? And I'm going to put 3, 1, 2, 3. Put a third one out here. Now we're starting to look like a boron atom because we have 5 electrons and 5 protons. It's kind of its dog tag, its identity is the number 5. So 5 protons and 5 electrons. I'm just going to write that so that it makes sense to me so I don't forget it. 5 protons and automatically 5 electrons. Yeah, I'm going to put a little plus by the proton and a little negative by the electron. Now I've got myself some good notes, but I'm lacking one thing, and that's sort of the mass, the thing that makes it chubby, adds the bulk to it, and that's the number of neutrons. These are neutrally charged things that are in the nucleus. And the way to get that is I'll take the atomic mass right here. I'm going to go with 11 because that's closer. And I'm going to subtract the atomic number. And that gives me 6. So that means inside here there's 6 neutrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And all spread out throughout there. So that's how you would make a boron atom. Okay? So I'm going to ask you to replay that if you want to. And then I'm going to challenge you to make a lithium atom. Same way, a lithium atom. Let's see what you can do. I'm going to write it out and make the square nice, big, and fat. And then I want you to pause it and work ahead of me. Okay, so review how you made the boron atom. If you have to go backwards, rewind. Go for it. And I'm going to make lithium nice and big. I'm going to end up making this atom myself, but I want you to work ahead of me and show me that you've got it figured out. Here's Li, lithium. It's a soft metal. It's kind of like a cold butter when you cut into it, except for a second it's shiny. And it's a little bit like an apple. You know how an apple turns brown when you bite into it? It's white and then it oxidizes and turns brown. Same with lithium. When you cut into a bar of lithium, it sort of oxidizes real quick in the Earth's moisture. Anyway, if you throw a little bit of lithium in water, it explodes. I'll try to do that for you during this unit. Okay, so pause it right now. Pause it. I've got the, and I want you to label the following things. I want you to write, where is the atomic number? Where is the atomic number? Where is the atomic mass? If you can already answer these questions, you are ahead of where you were last week. Because I know down at Loch Riel they threw away all of their periodic tables about 10 years ago, and they don't teach this stuff anymore. Okay, atomic number, atomic mass, where is it? Which one of these tells you how many electrons and protons? And even better, what is the charge on an electron? What's the charge on a proton? And then how do you figure out the number of neutrons? So pause it and see if you can answer all that before I do. Okay, I'm about to do it, but I want you to pause it and see if you can beat me to the punch, which would show that you have mad periodic table skills. Okay. Here I am. I'm going to draw a lithium atom. You hopefully paused it and you've beaten me to the punch. And that's what I get for messing with your superior intellect. Okay, so here we go. I know for a fact that the atomic number is 3. That's going to be the number of protons in the nucleus. 1, 2, 3. Protons are my favorite subatomic particle because they're positive. I also know that the number of electrons on the innermost shell, it fills up. I'm not going to have any more than 2 on that inside shell because it fills up with 2. So there's 1 negative charge. And I'm drawing it in orbit around the nucleus, buzzing around all over the place. That's 2 electrons. Now I know I'm not balanced. I've only drawn 2 and I have 3 positive charges in there, so I'm going to add 1 more. Lithium has 1 electron in its outermost shell, which is the reason that you throw it in water, it explodes. It's extremely reactive. I'm going to add a little plus sign to all my protons, because that's a good Bohr model, lets you know that, right? Okay, now it's time to figure out neutrons, and you probably beat me to the punch. You figured out that 6.9 is a lot closer to 7 than it is to 6. That means on average, most of the time, the atomic mass of lithium is going to be 7. Quick subtraction problem. 7 times 3, or minus 3, I'm getting rid of the atomic number here, the number of protons. That leaves me with 4 neutrons in the middle here. So most of the time, lithium atoms have 4 neutrons. Sometimes they have 3 neutrons. They can still be lithium with 3 neutrons, but you can't be lithium with less than 3 protons. So that's what a lithium atom would look like. And we'll keep at it. We'll do this again. All right?